And on this one, let's go area. I think you'll like this. A lot of geometry today, children. A lot of geometry. Area. And our area of this one is complex shapes. I think this is what we called it last year, but actually this book calls it combined shapes, I think. Combined polygons. What? We did this?
Yeah.
Well, then forget it. Take out a blank piece of paper and write circles on it. I thought we spent the whole day just doing.
You did that. I know we did.
Well, you guys are farther than I thought we were. Oh, wait, no, take out a blank, I'm sorry. Take out a blank piece of paper and write equations on it. We got some work to do, ladies and gentlemen. This, though, I don't find that difficult. I'm going to take my glasses off so I can focus. Ready, Mom Gardner? How do I know that? Usually you cheer. Pick up parade or something. Okay. No longer, ladies and gentlemen, no longer are you going to solve equations by inspection. No more solve by inspection. The reason they did that was to kind of give you a gist about why we're going to do what we do today. So I am going to write down the 4 types of equations that we're going to talk about. One of them is we've got an addition equation, which would simply mean this: x plus 6 equals 13. A subtraction one, which maybe is x minus 15 equals 90. Let's do a multiplication one, which would look like this: 3 times x equals 81. We don't just put the sign there because we put the letters. And then a division one that looks like this. X divided by 6 equals 36. Okay, got that? These will be your base sort of things. Now, here is what you need to think about with equations. Number 1. The first thing you have to think about is you want to do what we call, I'll give you the mathematical term, you want to isolate the variable. By variable we mean letter. In the end, I want to know what x equals in all of these. If you're isolated, if you're in isolation, that means you're by yourself. I want to get the letter x by itself. Okay? Step number 2 is I want to think opposite. Think opposite. Brody, you with me on thinking opposites? That means this. Whatever type of equation it is, you are going to do the opposite mathematical operation to solve it. This is an addition equation. I'm going to subtract when I solve it. This was a multiplication one. I'm going to divide. This one was subtraction. I am going to add. And this one was division. I'm going to multiply. I always think the opposite of what I see there. And then the last thing I want you to think about when you do these is, step number 3, is what you do to one side of an equation, you do it to the other. What you do to one side of an equation, you do to the other. It's mostly because that's what keeps the equation what we call balanced. Okay, you always think about an equation like being a balance. I know Mrs. Stone goes over all the balances with you here, there, sometime, right? Don't worry. That happens all the time. Oh boy. Until I don't use this bad boy very often, do I? Oh boy. The scales of justice are sitting right here, children. by equations. It doesn't. This one doesn't work. But one of these days, I'm gonna get myself a good one of these. You always think of an equation like a balance. Because of the equal sign, the two things on either side are equal. I hate this thing. Does that make it balanced? Does this make it balanced? Oh, look at that was better. Is it close? Let's try this. Yeah. See, the deal is with an equation. Just put that all the way there. Wait, why would that make it more better? More better? Wait. I eventually, don't you worry. Let me just throw some paper in here to try to get the balance out. Is that balanced? Too much paper? Too much paper. We'll go halvesies. Is that balanced?
No.
Anyways, the deal of what I'm telling you is when you see an equation up there, like that equation right there, okay, you have to think that both sides of the equal sign are even or level. So when you do solve an equation, let's say you have to add something. You know, let's say I have to add something to this side. Okay, it's not back to being balanced until I do the exact same thing to the other side. That's magic. Ooh. Right. So that means this. Watch how, this is a piece of cake. Okay, if I want to get this one, let's look at this equation right here. If I want to get my x by itself, I have to get rid of this plus 6. Well, the opposite of adding 6 is subtracting 6. If I have 6 and I take 6 away, guess what? I got nothing. I got nothing but this little x left. Okay, that's my thinking opposite. I was adding 6, I need to subtract 6 to get the x there. But that's not right, because if I take 6 away from this, it's like stepping up to my little balance and saying, okay, I'm taking 6 away from this side. If I take 6 away from that side without doing anything to the other side, it's not balanced. Which means I have to also subtract 6 from 13, which gives me 7, which is the answer to that thing. Which is, here, I take away my 6 from that side, it goes back to being balanced, and everybody is happy. Which is when you did solve by inspection, that's what you kind of did mentally. You said, okay, what number when I add it to 6 is 13? Well, you would subtract an answer. So watch how fast the rest of this goes. This one's a subtraction one. So to get rid of my minusing 15, I add 15. Because if I have a negative 15 and a plus 15, whatever, I have nothing left but my x. But I have to do the same thing here. I have to add 15 to that because I added 15 to that side. So my answer is x is 105. This one here happens to be a multiplication one. To get x by itself, I need to do the opposite of multiplication, which is divide. And the way you show divide like this is do this. 3 divided by 3 is, it doesn't really go away, but it gives you a 1. 1x is x. I divide this by 3. 81 divided by 3 is 1. This one here, those of you that are thinking the answer was 6, because 6 times 6, that's not how this works. This is x divided by 6. The opposite of dividing by 6 is multiplying by 6, which really would be 6 over 1. And look what happens. The 6's cross cancel, and I'm left with just my x. But if I multiply this side by 6, I have to multiply this by 6. And 36 times 6 is what? 36, 3, 216, I believe. And that would be your answer there. That's it right here. 216. See how easy these things are? There's really, the mental way is kind of a good thing to get you, tells you what to do, but, you know, and you'll, this is exactly what you're showing me every time. Now, the one oddball that I have to show you that will come up a bazillion times, and half of you will ask me on a daily basis, and I'll say, why don't you remember what we talked about here? If there is a fraction in front of the letter, 1/2 x equals 3/5. This always throws people for a loop. Okay? I'll give you the long story, Ethan Malis, and then I'll tell you the short version of this. Well, what type of equation is that? It's multiplication. The opposite of multiplication is division. But I'm dividing by a fraction. How do I divide by a fraction? What's the rule for dividing by fractions? Flip and multiply. Yeah, so we're skipping all the whole gory stuff, and I'm going to tell you, if you have a fraction in front of the x, you are going to flip and multiply. Repeat after me. If I have a fraction in front of the x, I flip and multiply. So this is all you do. Here's the work that you show for this. You flip and multiply. Because these will cross off, because everything does. And I multiply this side. I multiply this side by 2 over 1, so I multiply this side by 2 over 1. My answer is 6/5. It's just that easy. If this was if it was 7/8 x equals 4, to get rid of that fraction, I flip and multiply. 4 times 8/7, which just so happens to be 32 over 7, and I'll let you even keep it as 32 over 7 rather than making it 4 and 4/7. Are you with me on that? I guarantee you, at least half of you will say, what do we do when there's a fraction in front of the letter? And I will say, flip and multiply. Let's look at some harder ones. Are there harder ones? Not really. Now, the reason this is nice is because now you're going to start getting equations that have, how about this one? X plus 1/2 equals 5/8. What type of equation is it? Addition. How do I solve it? Opposite of addition is? So I'm just going to subtract the 1/2. What I do to one side, I have to do to the other. I subtract 1/2. Unfortunately, it's a fraction, so I have to make common denominators. 5/8 minus 4/8 is 1/8. That would be the answer. Or what if it's a decimal? X minus 3.6 equals 3.5. How do I solve that? The opposite of subtraction is? Addition. So I add 3.6. What I do to one side, I have to do to the other. Add 3.6, and I get 7.1. And don't, well, how about this one? 1.2 equals x over 4. Don't let what side the letter is on the equation scare you. You can always flip-flop. I could put the x plus 4 over here and 1 over there. If it's equal, it doesn't matter what side it's on. But what type of equation is this? X divided by 4. So to solve it, I'm going to multiply by 4. Multiply by 4. The 4's cross off. I'm left with just my x. X is going to equal 4.8, right? Am I right? Am I right or am I right? I am right. I don't know if they give you any harder ones than that. Now the real question is, sure, why not? I hate to overload you, but this will be easy. I'll make it look easy. Sure, it'll be easy. Should it be easy? Maybe not. Now take out your notes under circles. Blank piece of paper with circles. Everything you want to know about circles, but we're afraid to ask. Basically, we're going to talk about two different things with circles. One of them is the circumference. Which is the distance around. And what is my circumference formula?
R times diameter.
I don't get this to work yet. Did it work? Did it work? Did it work? circumference equals pi times diameter, which we abbreviate as C equals pi times diameter. The other one is area. And if you remember, the thing with area of circles, it's a little like this. How many of you get your pizza cut in squares? When I order my one from Papa John's, I cut it in squares. But the problem with squares, Anna Baumgartner, is, if you're sharing it with your family and, your mom says or your dad says everybody gets 6 pieces, they're not all actually equal squares. The nice ones in the middle are, if you are the greedy one in the family, they cut it into squares. You each get 6 pieces. Well, Anna takes the 6 in the middle. They're all nice squares, and then she leaves whoever with the 6 outside pieces that are just little wedgy, little small pieces. So cutting a circle into squares is not easy. We did it last year, and we found the formula was area equals pi times radius, or, ladies and gentlemen, area equals pi r squared. Now, a couple things to note about this. Let's go back to circumference. The book will tell you one of 3 things to leave your answer. Got that? They will either say to leave it in terms of pi, which if you see that, you should smile because that's the easiest of all. And what they're telling you is you can just leave the symbol for pi rather than doing any mathematical calculations with it. For example, if my diameter is 6 inches and you're asked for the circumference and they tell you to leave in terms of pi, you just write circumference equals 6 pi. Because the diameter is 6, and you can just leave the symbol pi for that, and that's your answer. That's option number 1. Option number 2 is they might say to use 3.14 for pi. If that's the case, you can't leave it like this. You have to actually take circumference and multiply 6 times 3.14, which gives you what? 18.84, whatever that is, inches. Now the third option is one we don't see very often, but they will tell you this, okay? You can use the fraction for pi. You can use 22 over 7 for pi. Now why, and this is a question you're going to ask me, why in the wide, wide world of proverbial sports would I want to use 22 over 7 for pi? The only reason you would ever do this or ever want to do this is if the circumference is a multiple of 7. And I'll show you why right now. The book likes to just mess with you a little bit with this. If you're trying to find the circumference of a circle whose diameter is 14 feet, and the book says use 22 over 7 for pi, your formula would look like this. Circumference equals pi is 22 over 7. And I'm multiplying that by the diameter, which is 14. I make that a fraction. What happens? Well, the 7 and the 14 you can cross cancel. 7 goes into 14 twice, and your answer is simply 44. Much easier than doing the whole decimal 3.14 times 20 or 14 or whatever it is. So the only time you're ever really going to want to use the fraction is if this is 7, 14, 21, 28, 35, 42, 49, 50. any multiple of 7, and it's really the same thing for area as well. You know, if the area of a circle, you know, if I had this circle and I said its radius was 7, well, the formula says I take 22 over 7 for pi, multiply it by 7 over 1 times 7 over 1. This 7 crosses off of that 7, and your answer is whatever you get when you multiply 7 times 22, which is what? 154 inches squared. Now, how do you like that? Does that not sound like the best thing since sliced bread? Anybody? Do we have enough time to talk one more thing? Under the area of a circle here, take a look, see here, because this is one other thing the book will throw your way. When you have circles, we have pi pieces. But in math, we don't call those pi pieces. We come up with the highfalutin words. Anybody know what those are called? This is called a sector. It's a pi piece. Okay? And they're going to ask you to give the area of that sector. Area of that sector. But they have to give you a little bit of information there. Okay, they're going to tell you what this angle is, and they're going to tell you what this dimension is. Maybe it's 4 inches. And they're going to ask you to find the area of this little pi piece. Well, boys and girls and children of all ages, start with what we know. We know how to find the area of a whole circle, correct? What is the formula for the area of a whole circle? Area equals pi times radius, correct? But I don't have a whole circle, I only have a fraction of the circle. How would I figure out what fraction of the circle I have? Well, I know this is 45 degrees. How many degrees are in a whole circle? 360. So, to find out what fraction I have, I take 45 and put it over 360 and reduce it. If you reduce it, you get 1/8. So if I take my whole circle and divide it by 8, which is multiplying or whatever, finding 1/8 of it, that will tell me that little portion right there. And I would advise you, I would see, this is where being mathematical wizards you are, Jonah. Rather than doing the whole problem out and then dividing by 8, but by the way, I'm going to say leave this in terms of pi, which should make you smile because you don't have to deal with 3.14. What is my radius of that circle? So it's 4 times 4, right? Over 8. Rather than multiplying 4 times 4 or whatever, well, I guess you could do that. Sure, let's do it. 4 times 4 is 16. You get 16 pi all divided by 8. Well, what is 16 divided by 8?
8 pi.
2 pi. And in my world, 16 divided by 8 is 2. Not sure where you're, what kind of pi you're using there, but how about that for being fun? Guess where we are?
You're at 40.
We are in Circumference. Good, then I'm going to give you, look at you caught up to the other class. I'm not sure how good we know it, but you caught up to the class. You are going to do this, just the practice on lesson number 40. Just the practical lesson number 40.